All right, it's 2 o'clock on my watch. Let's get going. So good afternoon, everybody. My name is Arkadiy Shapiro. I'm a product manager at Barefoot Networks, which, in case you haven't heard, is now part of Intel. Still doing the same things, if you have heard of us, but just now part of a bigger mothership focused on programmable data planes, programmable ASICs, and of course powered by an open source language called P4, which we'll talk a little bit about that in the presentation. So today I wanted to talk about the use cases of programmable silicon in the disaggregated network. And if you think about disaggregation, there's been a lot of talk about that. But with disaggregation and with things becoming more open, the last thing that was still remaining closed was the data plane. Right? So control plane became open. We have projects like Stratum and Sonic. You could do, have the source code, do whatever, to your heart's content. But the data plane was remaining to be closed. And this is what we as a company were set out to change. So we saw a general industry trend that there's a domain-specific architecture for all kinds of things. Right? Obviously, there were CPUs. Right? Now I should kind of talk more loudly about CPUs being part of Intel. But there's GPUs. And yesterday, there was a nice keynote from Facebook about AI and machine learning. And Misha talked about how important it is to have programmability in a machine learning environment. And I think he mentioned the compiler that Facebook uses, which is Glow. Okay? And we felt that networking shouldn't be any different. And with networking, there should be a compiler, and there should be a language to program those data planes. Okay? And that language is called P4. Now, what this really means is that in case of data plane programmability, instead of the switch telling us how the packets are being forwarded, we are actually telling the switch how to forward packets. And by we, it could mean a vendor who is building an OEM system, a disaggregated switch operating system vendor, right, like IP Infusion or Cumulus Networks or anybody else, or the end user themselves who perhaps has a source code to that operating system, whether it's a commercial operating system or an open source operating system like Sonic or Stratum. Okay? So this is what is meant by really user-driven, right? User, in this case, could mean many different things. Okay? Now, programmability, today, sometimes it's kind of like SDN, right? A lot of vendors, everybody talks that everybody has some sort of programmability. I'd like to kind of share what our definition of programmability or data plane programmability is. We believe that if you want to call a solution programmable, if you want to call a data plane programmable, it has to meet all of these requirements. Number one, you got to have an open language for which there's a community around it. Right? So in some cases, there's a language, but there's no community. Okay? Number two, looks like my thing keeps flipping, having a compiler and a chip simulation model that's available to end users. Number three, having visualization tools that helps you actually debug your program and figure out how it's using the resources of the chip. Number four, having the flexible and auto-generatable APIs. And number five, of course, having a fully programmable ASIC. So as an intro, we'll go kind of through, I think, most of them, starting off with the language. So a quick plug on P4 for those of you who are not familiar. P4 is a pretty vibrant community now. There's lots of different vendors, participants, not just from vendor side, actually, but also from end user side. Right? Folks like cloud customers, telecom operators, folks who you would have thought would have never done data plane programming before, but they're actually doing it now. Now, on the silicon side, of course, we have 2 types of silicon. One is called Tofino, which is, goes up to 6.4 terabits. The other one is called Tofino 2, which goes up to 12.8 terabits. But us being silicon vendor alone, we got to have an ecosystem to make something happen, to make any of these use cases, which we'll talk about later, happen. So that's the ecosystem. Right? So we'll talk about the white box vendors, the ODM vendors. And here I'm listing ODMs, but actually, probably in the last few OCP summits, you start seeing some of the traditional OEMs, right, like Cisco and Arista, getting into the disaggregated bandwagon and starting to support Sonic, right? Not only on Barefoot-based systems, but also on systems from other vendors that they have. Okay, but these are the white box vendors that have Tofino-based systems, and then these are the switch operating systems or fabric solutions that we work with, right? In some cases, there are more box-by-box operating systems. In other cases, really the solution comes with a controller in mind, right? So something like Kaloom, which offers a controller, right? Or something like Stateness, which is actually a fairly new vendor that just launched this week with a very specific fabric solution based on P4-Programmable switches for co-location environments, right? They also have a controller of their own. Okay. Now, since we're at OCP, to focus a little bit more on which switches have the most tie into OCP, we work with a company called Stortis. They're actually the first ones to become OCP accepted and to have Tofino-based switches that are OCP accepted. And one of the cool things that they have is they have a timing chip on top of the P4-Programmable chip, which is Tofino. They have a timing chip there that is used for specific requirements around telcos and financial services. But aside from that, very kind of a typical configuration where they have a 64 by 100 gig, and then they have a 48 by 10/25 with 800 gig uplinks. Right? And in one case, in that secondary switch, they can actually do some 1 gig ports there as well, which is, I know, important for a few customers. Okay? And then there are several models from both Edgecore and Inventec that are, I would say, in the class of OCP inspired, but not in the OCP accepted yet. Okay? Now, I would encourage you to talk to all of these different vendors and kind of check on their OCP status. We definitely encourage them to submit their designs, but us being the silicon vendor, we have no control over that. That's really a responsibility of their own. Now, I talked about the disaggregation system and how programmability actually makes things more open. The dataplane programmability makes things more open. But that poses maybe a little bit of a challenge because, well, now you have a lot more things to play with. And the typical question that comes up is, well, who's going to be doing the P4 development, and who's giving the system, and who is giving the software? And I sort of built a little chart here where we can have some examples, right? Where if I say that, let's say I'm using our silicon, and who's going to be doing P4? Well, anyone could be doing P4. An ODM vendor could be doing that. We could be doing that. And we actually have some reference P4 programs that are provided as part of our software development environment. Or an end user, right? An end customer who is perhaps using Sonic could be doing that. So let's say an end user is doing that. And they're probably using Sonic because if you're changing the data plane, you really have to have a control plane that's open, right? If the control plane is closed, then they're the ones who are controlling the data plane, right? So in this case, your most likely bet for a fully open control plane is Sonic. Okay? And then, of course, right, you would pick from one of these ODM vendors to actually put your control plane and data plane on. Okay? So that's kind of your options for building a complete solution together. That's how things can come into place. Okay? Now, in terms of how actually a P4 program gets loaded on the switch, this is a high-level picture of our software development infrastructure, software development environment. We have a P4 compiler that takes the P4 program, compiles it, and loads it onto the chip. And then as part of that, there's a set of APIs that are provided. From a lower level, program level APIs that deal with P4 level tables, up to a higher level API, which is SAI, which goes on top of a reference P4 program that we provide. Okay? So if, for example, if you're a Sonic, you want to talk to the chip for SAI, and that's what we will do. But if you're using an operating system like Stratum, which just got open sourced a couple weeks ago, then you would be talking directly to the P4 level APIs using a protocol called P4 runtime. Okay? Now, there's multiple schools of thoughts, right? Some people like SAI, some people like other ways to talk to the system or talk to the chip. From our side, we're pretty agnostic. We try to support both and not to have a religion of one versus another. Okay? So, and if you've built that P4 program, sometimes you might have a situation where you might want to change it. Right? And this is an example of what we've done with Sonic, where actually as part of our Debian package that is upstreamed into Sonic, we have multiple data planes that are provided there that a user can switch from. And then, of course, somebody who is doing their own development, they can keep adding onto that. So there's a configuration file that you basically select the right profile, and then you reboot the switch to have it take effect. Right? And on the right, you'll see that some of the profiles that we're providing that are already bundled in and upstreamed as part of our Debian package. Okay, so that's an example, basically. In one case, we're just using some foundational features plus data plane telemetry. In another case, we may be doing a Baremetal deployment where the requirements are slightly different, and the focus is really on a high-scale VXLAN tunneling versus perhaps something else. Okay, so that's kind of going to the use cases of programmability. That's one example here. Now, since I mentioned Stratum, I should highlight that it's a new disaggregated operating system that just got open sourced. It's been in development for a couple of years now, primarily driven by ONF with a seed code from Google, but lots of other vendors participating, ODM vendors, silicon vendors, both Barefoot and Broadcom have implementation on Stratum. And also a lot of interest from telecom vendors who kind of see Stratum as this next generation SDN solution, right? Part of this next generation SDN solution. Right? So in this case, you have a solution with a controller that talks to the switch using a protocol called P4-Runtime and loads the P4 program down to the switch. And the key difference here is that Stratum is a thin stack operating system. Right? So those of you who are familiar with the kind of early open flow solutions and solutions where the control plane was really sitting on the controller and the OS on the switch was really thin, there was no protocols running on the OS. This is something similar. It's the next generation of that. Okay? So there's some examples of the types of data planes that folks have written to, primarily folks at ONF, with contributions from the community members. And right now, there's about 3 ODMs, both from Barefoot-based and also Broadcom-based that are supporting Stratum OS. Okay, so I encourage you to take a look. That's actually the GitHub link that now should have the open source code. Now, going back to the use cases or the benefits of programmable switches, we typically like to look at it in these 5 buckets. Number 1 is reduced complexity. Okay? And reduced complexity could mean less features running on the data plane. And that also means that less features exposed using the APIs. Right? Because remember that one of the requirements of programmability is that my APIs are fully auto-generatable. So if I'm not using a feature, I don't have an API to program that feature. So that means that a potential solution that I'm building that's maybe not just a typical top-of-rack switch, but something a little bit more unique like a gateway or a packet broker could be a little bit more clean and flexible. Okay? Future-proofing is kind of an obvious thing, right? Some new protocol comes along. You want to be prepared for that. That's where programmability can help. Scaling. That's also another obvious one. Being flexible to have a v6-centric network, v4-centric network, based host-centric or longest prefix match-centric. And finally, data plane telemetry, being able to actually detect events in the network right at the data plane without having to kind of put a lot of data onto the CPU and do a lot of polling and things like that. Okay. So going to the use cases, as I said, scaling is probably the simplest one, right? When you can have a more flexible way to scale your tables to say, I want to be focused on v4, I want to be focused on v6. Update the network really with changing network conditions because you really can't predict, right? The table size that are changing, there's more and more v6 coming along. What you have planned for today when you say that, hey, I want X number of thousands of v6 routes, and that's what the P4 program should be, you really don't know what it's going to be tomorrow. Okay? And this basically allows you to change that and adjust to the changing network conditions. So that's a couple of scenarios that you could have, right? In some case, it's host-centric or LPM-centric, v4-centric versus v6-centric. Another one is cloud gateways. So this is an example of uCloud, which is one of the fastest growing China cloud companies. some folks may not have heard about. I know typically folks hear about Tencent and Alibaba, but uCloud is becoming actually pretty prominent. And like many cloud customers, actually see this pretty much in every case. With the growth that they have, the traditional switching solutions just were not enough for them to have a very scalable gateway. Whether it's V6 gateway or NAT gateway or VXLAN gateways where they need hundreds of thousands of tunnels. So what they ended up doing is they ended up taking all of that stuff to the server. Now, myself being Intel, I like servers and I like DPDK and I like CPUs. But I also know that that wasn't scaling for them either. And uCloud, just like many of these customers, worked to take that back onto the data plane, using before they developed their own solution. They actually used Open Network Linux, took FRR, and pretty much built their own operating system. Right? So the value for them was basically higher performance, more flexibility and control that they could have. And I would say another iteration of a gateway or tunneling encapsulation type of application is the demo that we were doing at the last OCP summit. This was actually a multi-vendor demo with multiple folks, Barefoot, Mellanox, Novium, doing VXLAN gateway in this kind of one big spine leaf network, what we call disaggregated chassis. So here, this is actually an Arista 7170 Barefoot-based switch running Sonic and doing VXLAN tunneling. Now, again, in case, because it's a multi-vendor network, we maybe were not showing all the possible kind of things that we could do on the programmability side because we needed to kind of make sure that the same features and scale and functionality are running across all of the different vendors. But that's one other case where programmability or data plane programmability could help you do some things that you couldn't have done before, right? Particularly on scale and flexible tunnel encapsulation and decapsulation. Okay. Now, I mentioned machine learning before. So again, Facebook had a nice talk yesterday morning. And we worked together with Microsoft and a couple of universities to develop a data plane that actually helps accelerate the machine learning. So in cases of machine learning where you have lots of different switches doing lots of heavy computation, we actually ended up having the switch, well, servers doing heavy computation, but we actually ended up having the switch do some of that computation to offload that work from the switch, and as a result, have up to 3 times acceleration of how quickly those workloads can complete. Okay. So there's a reference for the this paper that was presented at one of the P4 workshops. Again, was done in conjunction between us, Microsoft Research, and a couple of universities. Now, when you talk about simplicity, and you remember I mentioned kind of simplicity of APIs, the fact that the APIs are auto-generated, and I mentioned packet brokers. So here's some more information about packet brokers. Again, the reason why people start doing packet brokers with a programmable data plane, primarily I would say is this first bullet on the top, right? Is making sure that I'm only using the chip for what I need. And the needs for a packet broker are very different than the needs for a top-of-rack switch. Okay? And after that, what they can do is some of those additional things like stripping headers in a flexible manner, encapsulating, decapsulating tunnels, load sharing, making sure that the TCAM is really used for the policy-based routing that is needed on the packet broker-based network versus some of the other things that the TCAM could be used for. Okay? And on the right, you'll see kind of all the examples of folks who have built solutions based on a programmable data plane and P4 have built packet broker solutions. So there are telecom vendors, integrators, OEM vendors, disaggregated operating system vendors, kind of all across the board. Okay. The other scenario, and this goes a little bit more into the kind of new protocols and future proofing, is something that a company called Kalum, which I mentioned earlier, has done. Is they build a SDN type fabric with a controller, where on top of just doing regular switching and routing, they do some interesting thing from a 5G standpoint, where they do GTP tunneling, encapsulation, and decapsulation. Again, some more flexibility that they're able to achieve out of a programmable data plane. telemetry I talked about in the beginning. This is one example of actually a multi-switch demo. All of the switches were running Barefoot. All of them had a P4 data plane that was doing data plane telemetry, that was doing things like intelligent detection of events, right? Not just polling based on data, but detecting when you have a microburst, when you have a latency spike, when you have a packet drop, and sending that data to a collector, right, to an analytic system, which we call Barefoot Deep Insight. Okay, so in this case, you had some spine switches from H-Core. Some of them were running Sonic, some of them were running IP Infusion OcNOS. And then some leaf switches from Cisco, which were running Cisco NXOS, all running the same data plane that was doing data plane telemetry. Okay. And finally, in terms of emerging technologies, so those who are in the telco communication service provider space have been looking at segment routing v6 quite a bit. Now, segment routing v6 is a fairly emergent technology. And actually, a couple weeks ago, I've been hearing that there's somewhat of a competing standard or competing proposal. You could say that. Maybe somebody else would disagree. But the beautiful part is we really don't care. If you think it's better, you go and implement that. And if somebody else thinks it's not better, well, then they stick with what's been done before. So that's, I think, the segment routing. I think it's segment routing v6 plus. Right? Yeah. So that's kind of one of the values, is that in the case where the technologies are still evolving and the standards bodies are still debating as to what's the right way to go, it's really hard to burn something into the chip and then kind of expect that to change. Okay. Right. So a couple things in terms of a call to action. I invite you to try out these use cases using the OCP accepted or inspired hardware, and then using any of these operating systems. Or, of course, trying to build your own. Like I mentioned, in some cases, folks just do take Open Network Linux and FRR. That really depends on how much engineering effort you would want to dedicate. Sonic really provides a nice starting point to be able to do some of those things right away. And of course, exploring new use cases. I invite you to work with the networking group with OCP. And of course, get more familiar with P4. Okay, so with that, any questions? Yes. Yes.
Barefoot came first with encoding for event telemetry, but by now we have 4 vendors all doing different things. So in ATF and IPPM, we are trying to align the format. Are you doing anything trying to?
So in terms of aligning to a common in-band telemetry format in ITF, there's IOAM, right?
Yeah.
Yeah. So we can support IOAM. It really depends on who wants to do it. Either somebody implements it themselves. We've done actually some proof points in like Plugfest where we could implement IOAM. Then it's just a matter of, do I ship a reference program as part of my SDK? If I have enough customers who want it, I'm just putting my product manager hat. Right? Then I could do that. Or I could just say, look, it's been done before. There's a P4 program that's available. But then maybe all the additional APIs like SAI that you may need to do on top of that, they will need to be developed. Right. But yeah, that goes back to this future proofing and also with the technologies that keep changing. Right? We are fairly agnostic. Right? Our belief in general is to try to do as many things in the data plane as possible. And not to send too much things to the switch local CPU, right? Not to send too much data even to the collector. That's why there's intelligent detection triggers on the chip and also on the P4 program to make sure that we only send when there's an event and we only send the right amount of data. Okay? Yes?
One of the things that really helps myself and my lab engineers develop and test things is having a simulator of the platform that I can fire up in a VM or something. And in the case of P4, the thing that seems to be like the best candidate for that is the P4 soft switch in Sonic.
Yeah.
Except that build has been broken for almost 2 years.
We should look into that.
Yeah, I actually opened a GitHub case, and the Sonic people told me to talk to Barefoot, and I opened a Barefoot GitLab case and didn't see anything. If there's anything that you could do to make that work,
Okay.
I really appreciate it.
let's talk offline. I think one thing to keep in mind is that the P4 soft switch implements kind of a generic pipeline. It does not implement a Tofino pipeline per se, but that may be good enough for some of your use cases. Yeah. Yeah. No, makes sense. Makes sense. Yeah. Yeah. I think it's one of those projects that hasn't been updated for quite some time. But yeah, we should talk offline after that. Cool. Thanks. Okay. I think we're getting out of time. I don't know. Yeah, we're like at 2:25. So I'll wrap up if there's no other questions. Thank you very much.